14.7 Apply double angle and half angle formulas. And enjoy this little comic about ShapeUp, a geometry construction company. They have a wanted ad out for the right angle, and when applying for this math job, reference angles can be quite helpful. Anyway, we've come to the final lesson in your textbook for Honors Algebra 2 here. Yay! All right, today we're going to be doing some double angle formula stuff. So the first thing we need to know is what the sine of 2a is. The sine of 2a is simply 2 sine a cosine a. I know you're dying to know how I came up with that. Well, sine of 2a, think back to your last lesson, is just sine of a plus a, right? And so this was sine cosine plus cosine sine. And so we could rewrite that as sine a cosine a, and this is the same thing as sine a cosine a. We have the commutative property going on. Yeah, I'm taking it way back to the beginning of the year like that. And so I have two of the same things, 2 sine a cosine a. So I just did a little proof right there. You don't have to prove it again. You can just remember that. For the cosine of 2a, there's 3 common ways that we do this one. The first is that we think of it as 1 minus 2 sine squared a. The second way is 2 cosine squared a minus 1. And the third way is just cosine squared a minus sine squared a. And you'll see how one of these 3 forms will come in handy when we're doing some of these problems. In class, we can prove how you get from one to the other, but I'm just going to leave you with that for right now that you've written down in your notebook, and we'll apply that. And then the tangent of 2a is 2 tan a over 1 minus tan squared a. That one should come really obvious to you, because remember that we had that the tan of a plus a would simply be equal to tan a plus tan a over 1 minus tan a times tan a, which is equal to what we just said it was. Remember that we write tan a squared as tan squared a. So that's the proof for that one. And then we need to know what sine of a over 2 is. That's plus or minus root 1 minus cosine a over 2. The cosine of a over 2 is plus or minus root 1 plus cosine a over 2. So notice the one with sine has a minus, the one with cosine has a plus. And then the tangent of a over 2, you can think of it as 1 minus cosine a over sine a, or sine a over 1 plus cosine a. Now, I write these little plus or minus in these two, but when we do the examples, I'll explain that the sine, S-I-G-N, the sine of sine a over 2 and cosine of a over 2 depend on which quadrant you're in. So of course we're going to have to draw in these just like we've been doing in everything else. So let's go ahead and find the exact value of tangent of 3 pi over 8. In this problem we immediately know that we want to do a half angle thing because we know 3 pi over 4, right? We know something about the 3 pi over 4, and so 3 pi over 4 divided by 2 is simply 3 pi over 8. So we know we're going to be using one of those half angle formulas here. So let's just choose, why don't we choose this first one, 1 minus cosine a over sine a. Let me just write that. The tan of a over 2 is 1 minus cosine a over sine a. Okay, so let's go ahead and do that. So the tangent of 3 pi over 8 is going to be 1 minus cosine of 3 pi over 4. Remember, I just let my a be 3 pi over 4. Because this is a over 2, over sine a. And so what is the cosine of 3 pi over 4? Well, let me go ahead and draw. This is pi over 4. This is 2 pi over 4. Remember, you're just breaking it into fourths. Pi over 4, 2 pi over 4. 3 pi over 4 would be right here. 3 pi over 4 leaves us with 45 degrees as our reference angle. So we know this is root 2 over 2, and that's positive, and this is negative root 2 over 2. This is always 1. So the cosine would be 1 minus a negative root 2 over 2 over the sine, which was just the positive root 2 over 2. So we have 1 plus root 2 over 2 over root 2 over 2. Let's go ahead and get a common denominator in the top here. So put that whole thing over 2. So 1 could be written as 2 over 2. 2 plus root 2. Keep it, change it, flip it. And so now these 2's can cancel out, and we get 2 plus root 2 over root 2. Of course, we can't have that root 2 on the bottom, so let's multiply by root 2 over root 2. And so distribute, we get 2 root 2 plus root 2 times root 2 is just 2. All over root 2 times root 2 is 2. I'm not quite done yet because I could factor a 2 out of the top, couldn't I? 2, and I'm left with root 2 plus 1 over 2, and now my 2's cancel out, and my final answer is root 2 plus 1. So you'll see how we're putting together like everything we've learned all year right here. Very, very exciting stuff. All right, the sine of 15 degrees. Oh, boom! 30 divided by 2 is 15. So 15 could be written as 30 over 2. So I'm going to be using a half angle. And so we know that the sine of a over 2 is this thingamajig. So I'm going to write that. Sine a over 2 is plus or minus root 1 minus cosine a over 2. Now, in order to determine if it's a plus or the minus, where is 15 degrees? 15 degrees is in the first quadrant. So the sign is positive there, so I'm going to cross out the negative one. I don't have to deal with a negative one. Again, because sine of 15 degrees, you know that the sign is positive in quadrant 1, you can cross out the negative. So let's go ahead and apply the formula now. The sine of 15 degrees is going to be equal to positive root 1 minus cosine A, cosine 30, because we said our A was 30, since we're doing the half angle thing. And then, hopefully you know the cosine of 30 degrees now, but in case you don't, we can redraw our triangles. And so the cosine of 30 degrees is just root 3 over 2, root 1 minus root 3 over 2 all over 2. Now, the hardest part of this problem will be getting the common denominator. So we need halves on the top, so let's go ahead and do that. 1 could be written as 2 over 2 minus root 3, and that whole thing was over 2 in the bottom. So let's go ahead and 2 minus root 3 over 2, keep it, change it, flip it, and so we have root 2 minus root 3 all over 4. And so you can split up the radical. We have root 2 minus root 3 over root 4. And this one's really nice because root 4 is just simply 2. And so that's going to be our final answer. Don't get all nervous because I have the double radical thing going on. That's just fine. Just can't have the radical in the bottom. And so that's my final answer. In this one, we're going to be applying the same kind of thing that we did in the last section. So for this first cosine 2a, why don't we just use the first 1 minus 2 sine squared a. So cosine 2a equals 1 minus sine squared a. If you could have used any of those formulas, you would have gotten the same answer. So in this problem here, let's just draw it. We're between pi and 3 pi over 2 in this problem, so we're right here. And we know that the tangent is 3/4. So the opposite is 3 and the adjacent is 4. These both have to be negative. Don't forget your signs. And we have 3, 4, 5. The hypotenuse is always positive, don't forget. So this is 1 minus, oops, I forgot a 2 up there. 1 minus 2 sine squared a. And so we have 1 minus 2 times, what is the sine of a? The sine of a is negative 3/5, so we're going to have negative 3/5 squared. So we have 1 minus 2 times negative 3 is 9 over 5 times 5 is 25. 1 minus 18 over 25. Let's get a common denominator. 1 could be written as 25 over 25. And 25 minus 18 is just 7/25 is our answer. Now the cosine a over 2 is that plus or minus root 1 plus cosine a all over 2. Our cosine, remember our cosine is our x stuff, and our x is negative, so we are going to choose the negative one in this problem. So we get root 1 plus, what's the cosine? That would be adjacent, -4 over the hypotenuse, which is 5, all over 2. Let's go ahead and get a common denominator on the top. So we have fifths on the top. 1 could be rewritten as 5/5, so 5 minus 4 all over 2 is equal to root, oops, I lost my negative. Remember I was doing the negative one. Don't lose your negative. So we have 1/5, keep it, change it, flip it. So that is negative root 1 over 10, which is negative root 1 is just 1, and root 10 on the bottom. Rationalize that denominator, and we get negative root 10 over 10 as our final answer there. Same deal in this problem. Sine of 2a is just 2 sine a cosine a. Let's go ahead and draw this guy. So we are in, let's see, between 3 pi over 2 and 2 pi. So we're right here. And our cosine, which is adjacent, 5, 13. Hopefully you remember 5, 12, 13 from the other example that we did. So we have 5, 12, 13, but remember this one's negative. Don't forget your signs. If you mess up anything, it's going to be the signs. Don't forget your signs. Remember me saying that now. Never forget your signs. Okay, so let's go ahead and do 2. What is the sine of a? The sine of a is negative 12 over 13. And the cosine of a is what they told us, the 5 over 13. So 12 times 5 is 60, and 60 times 2 is 120 over 13 times 13 is 169, and that's going to be our answer right there. And then the sine of a over 2, well, that's going to be our plus or minus root 1 minus cosine a over 2. All right, so are we plus or minus here? Let's think. Where is a over 2? Well, a is between 3 pi over 2 and 2 pi. So that means a over 2 is between what? We divide everything by 2. So that's going to be between 3 pi over 4 and pi. So 3 pi over 4 is somewhere over here, right? And pi is over here. So that's going to be giving us a positive sign, right? Positive sign. You know what? I think I didn't explain that well enough in this one here. I didn't break it apart, I'm realizing. So since a is between pi and 3 pi over 2, a over 2 is going to be between pi over 2 and 3 pi over 4. So where does that fall? Pi over 2 is right here. 3 pi over 4 is somewhere here. So that's going to fall in this quadrant right here. And what is our cosine in that one? That's negative. Our cosine's clearly negative because that's the x-coordinate. So back to this problem, we know that our sine is going to be positive because we're dealing in this quadrant right here with our a over 2. And so we have 1 minus the cosine is 5 over 13. That was what they told us anyway. 5 over 13 all over 2. So let's get a common denominator on the top. That's 13. 1 can be rewritten as 13 over 13 over 2. Which is 13 minus 5, 8 over 13. Keep it, change it, flip it, and that can reduce to 4 over 1. And so we have root 4 over 13. Root 4 is 2 over root 13, or 2 root 13 over 13. Let's go ahead and try and find an equivalent expression. So let's break this apart. Sine of 2 pi we could rewrite as 2 sine cosine over, let's see, 1 minus cosine 2 theta. 1 minus, I'm going to choose to use that 1 minus 2 sine squared. Okay, So let's see what we can do with this. Let's leave the top for a moment. And then let's just distribute that negative. So we get 1 minus 1 plus 2 sine squared theta. And I'm really happy because the 1 minus 1 is just 0. And so now the 2's are going to cancel out. Actually, let me just rewrite this. I have 2 sine theta times cosine theta. And then I have the 2. And then I'm just going to write it as sine theta times sine theta, because that's what sine squared theta is. The reason I did that was because I wanted the 2's to cancel out and I wanted the sine thetas to cancel out. And so I'm left with cosine theta over sine theta, aka cotangent theta. Verify the identity. All right, why don't we break apart cosine 3x? Because we see that we could really break that apart. We could break it apart into maybe cosine 2x plus x, and then use the formulas that we've been using in this section, right? So that's going to be cosine minus sine. Now what I'm going to do is I'm going to break this apart even further. Remember that with cosine 2x, we had a lot of options for how we wanted to rewrite it. Because I'm going to be multiplying by cosine x, I want to stick with cosine stuff if I can. Okay, so I'm going to look back at my formulas, and I'm going to choose the one that only has cosine in it. I'm going to choose this one just because I was multiplying by cosine. That's just what I'm going to go with. And you'll see as you do more of these why you do that. 2 cosine squared x minus 1 times cosine x minus, and then the sine of 2x was just 2 sine x cosine x times sine x. So just keep going with this. Distribute that cosine x out. So we have 2 cosine cubed x. Woohoo, we have a cubed. Minus cosine x. And then we have minus, distribute this sine x out. We have 2 sine squared x cosine x. And so now what I do is I look back at what I'm trying to identify, and I note this only has cosines. Whereas I have cosine stuff, and then I have the sine squared. Whenever I see a sine squared and I want to convert it into a cosine squared, I remember that sine squared plus cosine squared equals 1. The way to change between cosines and sines is really when you have that cosine squared or that sine squared. So whenever you see sine squared or cosine squared, you're thinking in the back of your mind that you can easily go from cosines to sines or from sines to cosines, and that's the beauty of that. So our sine squared could be rewritten as 1 minus cosine squared, right? Because I just pulled this cosine over to that side. So that's exactly what I'm going to do in my problem. I'm going to leave that. I'm going to leave that. But I'm going to replace the sine squared with this, 1 minus cosine squared. Okay, so I'm making it a bit more complex right now, and then I'm going to break it down. So I have 2 cosine cubed x minus cosine x minus, and then I'm going to have to distribute this 2 cosine x to each of these. So I have 2 cosine x, and then a minus times a minus is a plus, 2 cosine cubed x. Again, I distributed negative 2 cosine x to each of these guys. So that's how I got 2 cosine x, and then I got plus 2 cosine cubed x. Okay, now just combine like terms. We have 2 cosine cubed plus 2 cosine cubed. That's 4 cosine cubed x. And then I have a negative 1 of these cosine x's minus 2 more is minus 3 cosine x. And look at that, I've just verified my identity. Now we have to solve. Let's go ahead and reduce this down using what we know, cosine x plus, and you better believe since I have a cosine, I'm going to choose that double angle formula that only had the cosines in it, because again, I want to stick with all sines or all cosines if I possibly can. And so that's why I'm going to rewrite this as 2 cosine squared x minus 1 equals 0. And so now I'm just going to put it in order from highest exponent to lowest. And now I'm thinking to myself, oh, maybe just maybe I could factor this, because this is like 2x squared. So I could have 2 cosine x times cosine x. That would make 2 cosine squared, right? And then how do I make a 1? A 1 and a 1. And let's see, our outer is 2 cosine x, and our inner is cosine x, and we wanted the outer and the inner to be positive, so we should make this positive and this negative. So this one is positive and this one is negative. Okay, that works. And so that leaves us with 2 cosine x minus 1 equals 0, or cosine x plus 1 equals 0. Remember, the only reason I could do this was because I set it equal to 0 first. Don't forget that. So we get 2 cosine x equals 1, cosine x equals 1/2, and lucky me, I'm only going between 0 and 2 pi. So where is the cosine? Where is the x coordinate? 1/2. Well, that's here and also here. It is 1/2 when this is 60 degrees or this is 60 degrees. So 60 degrees is simply pi over 3. That's going to be one of my answers. Since I'm thinking thirds, 2 pi all the way around the circle would have been 6 pi over 3. So if I fall pi over 3 short, that leaves me here at 5 pi over 3, right? So that's my other answer. And then what about this one? We have cosine x equals -1. Where was the cosine or the x coordinate -1? That would have been at pi. So my answers are simply pi over 3, pi, or 5 pi over 3. One more problem here. I'm going to scoot this sign over so I have sine 2x plus sine x equals 0. Do I have anything in common? And I hope you don't say sine x is in common, because sine 2x is not sine x times sine x. It's sine 2x. So I can't go doing that. Sine 2x is 2 sine x cosine x plus sine x. And now when I ask you is anything in common, now you can take that sine x out. In other words, 2 cosine x is left plus what's sine x divided by sine x? 1. Don't forget that 1. And so now, since I have something times something equals 0, I know this guy equals 0 or this guy equals 0. So when does sine x equal 0? That's when does the y coordinate equal 0? Well, the y coordinate equals 0 here and here. And I need a general solution in this one. So it happens at 0, at pi, at 2 pi. So basically at 0 plus pi k. And I don't need to write that 0. I could just say pi k. Okay, because I started here. I added pi, added pi, added pi, added pi. What about this one? 2 cosine x equals -1. Cosine x equals -1/2. Well, where is cosine? Cosine -1/2. That happens here and also here. So this would be my 60 degrees, and my 60 degrees, remember, is pi over 3. So if this is pi over 3, you knew this, let's think in thirds, was 3 pi over 3. So that would make this right here 2 pi over 3, fall pi over 3 short. And then if we fall pi over 3 over, that would make that 4 pi over 3. So either we start at 2 pi over 3 and keep adding 2 pi. So 2 pi over 3 plus 2 pi k. Or we start here at 4 pi over 3 plus 2 pi k. I can't simplify that down anymore because this distance here is not the same as this distance here. So since I have unequal distances, I have to start here, loop, 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 and start here, loop, 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 and so on. Okay, so I have those as my answers. And that's the end of this book. Dear Math, I am sick and tired of finding your ex. Just accept the fact that she is gone. Move on, dude. Teacher, noun, a person who helps you solve problems you did never have without them. And this final problem down here, you really should be able to solve if you think that you're going to be ready for this exam.
And that's it for this lesson.